This video will cover a couple of questions from the homework. The first one's going to be from 7.3 about the future value of an annuity. And it gives us what the payment amount each is for each time, and then how many years in our interest that's compounded annually. We're looking for the future value, and what we're going to want to do is use a formula for 7.3, which let me pull that up. And our formula for future value of an annuity, here S is the future value, R's are payments, and the problem told us what that was. I is the interest rate, which again we were told that, and N is the number of periods, which in our case is years. So we have all the values we need from the problem. We just need to plug them in here and calculate them out correctly. So here I put everything on one screen together, our problem text, and then the formula we need. So our future value is what we're solving for. We have our payments of 2,000. So we'll put that in for R. And then it's crucial that we follow the order of operations here and use our parentheses when we're typing stuff into a calculator, or else the calculator won't do everything accurately, and then you'll end up with the wrong answer. So our interest rate was given, our number of years is given, and our interest rate again would be down here. So following our order of operations, let's do that parentheses first, and you add those two values together and get 1.09. So now I'm going to pull up Excel for my calculator. So I want to do I gotta type an equal sign here. I want to do 1.09 to the 10th power. So exponents I need to do. I get that answer, I'm going to subtract 1 from it now. So I'm going to take that answer and subtract 1 from it. It's going to just change that 2 to a 1. So 1 point, and then my decimal. And then I take that answer now and divide it by 0.09. So my previous answer divided by 0.09. So I get this. So now I've done all the computations here. It reduces to a single number. I have S equals 2,000 times that number, which we'll look back at Excel to get it, 15.1929. All right, and so I'm going to take that answer and multiply it by 2,000. And then that gives me what my future value will be. That's our solution. The final problem I want to walk through in this video is from 7.4, using the binomial theorem to write an expansion out of a binomial like this. And I have another video that covers the binomial theorem in more detail, so I'm going to work through this one a little bit quicker. But we're going to pull that theorem up from 7.4. And here it is. Whenever you have two things added together, a binomial, you raise it to the nth power, it's going to follow this pattern here, where these are combinations. That gives you the coefficient. And then the exponents, they're going descending order for the first term. So it starts with n, and then 1 less, and then 2 less, and so on. And the last term won't have any of that first term, in this case x. There will be none of it. And for the second term, it starts off with none of that second. It's not present at all, and then each time the exponent goes up by 1. So you see the second term, and then it's squared, and then the third power, and so on, until that final term when it's to the nth. So here's the problem we're working with, and we're going to follow this pattern. So the first term, let's identify our x is 2z, and our y is minus 3r. So we're going to do our x to the nth power, so it's going to be 2z, that whole entire thing, to the nth, and I should say our n is 6 in this case. And the reason I'm emphasizing it's the whole entire thing, you're going to do 2 to the 6 as well as z to the 6. So 2 to the 6th power would be 64z to the 6th. That's going to be our opening term of our expansion. And then I'll worry about these coefficients later. We'll plug those in. But we're going to add, leave the coefficient out. Next, it's going to be 2z to 1 less, so now to the 5th. So 2 to the 5th and z to the 5th. So I'm going to get 32z z to the fifth, and I just plug in my y, which is minus 3r. So times minus 3r. And there's a coefficient here too, like I said, that we need to add in. And then we repeat that process, this pattern. The next one is our x term, which is 2z, and now it's to the fourth power. So that's going to be, leaving our coefficient now, it's going to be 16z to the fourth, because 2 to the fourth and z to the fourth. And then our y term, now it goes up one more. So here it was to the first power, now it's going to be to the second power. So negative 3r to the second power, that would be 9r squared. The two negatives, squaring the negative makes it positive, and r squared. And so you just repeat this pattern, adjust the exponents each time along the way, and the z goes up by one, or sorry, goes down by one each time, and our other term here gets multiplied by one more each time in the exponent. And eventually you're going to get this as your solution. So let me talk quickly about, and I can pull up Excel again here, to get these coefficients that we need. Like I have negative 576. Well, how do we get that? Oh no, I lost it. There it is. It says n, which is a 6, to the 1. That's saying do a combination with n things chosen one at a time. So you can, your calculator should have a combinations button. You can find them online. Excel has one, but if you have 6 things and you're choosing one at a time, how many unique groups can you get? And the answer is 6. And so that's what would go right here, is a 6. And the way we get our final answer for that coefficient is multiply all our numbers together now. So our 6 and our 32 and our negative 3. So altogether that gives us negative 576. So this second term, let me write our first term again. And then we have a negative 576, combining all our values, and then z to the fifth, r. And so that's where they're getting here. And I'll do one more. So 2160 they're getting for the second term. Well, how do they do that? Well, we look at the pattern is now at 6 combination 2. So it'd be combination, if you had 6 things and you make groups of size 2, how many unique groups can you have? Well, there's 15. And so 15 is our number that goes there. But we have to do 15 times 16 times 9. And that's where you get 2160. And this one's positive. And you had z to the fourth, r squared. So that's how you're going to proceed here and get all these individual terms. You'll notice the exponents always add up to whatever n is. That's one way to kind of check your work. We start off with just a 6, then we have a 5 and a 1 equals 6, a 4 and a 2 equals 6. The next one will be 3 and 3, and they'll always add up to 6. You're also going to notice a pattern in these combinations. What did we have here? This was 6 combination 1. This is 6 combination 2. What's 6 combination 3 comes out to 20. And you'll notice this with no matter what values it for n. So 6 combination 4, now we're back down to 15. And then 6 comma 5, now we're back down to 6. So it went 6, 15, 20, 15, 6. So you will see that same number show back up. Don't think you did something wrong because you're getting the same answer for 6 combination 1 as you do for 6 combination 5. That is what will always happen when we count combinations, the number of possible groups. And that, I think, sums up the process you need to go through. As I said, there's another video I have that goes into the binomial theorem additionally, so you can check that out as well.